Hello students, a very warm welcome to this lecture where we are going to solve this JEE advanced pattern. I have made you clear about the concepts of this chapter, that is dual nature of matter and radiation. Also we have covered the NEET pattern, the CBSE pattern, the JEE mains pattern, and now it's time to just take a look of the JEE advanced pattern. We have covered so many questions based on all those patterns, and as I have promised you that we will be meeting again in the next session with so many questions which will be based on this pattern. And so now we are here, and now without wasting much of our time, let's move to the first question and see what is the first question. Alright, so according to the question 4, question number 1, the direction has been given. Let me just introduce the exam of JEE Advanced before you. You will be encountered with 4 or 5 sections in your exam, in your JEE pattern, advanced pattern. In that pattern, you are going to see the match the following, the true false, fill-ups, comprehension type question, reason and assertion type questions, this multiple type of questions where only one option would be correct. The second one would be more than one option is correct. So basically there are sections which you are going to see in this pattern, right? Now the first question is, direction has been given that question number 1 to 4, each question has 4 choices and we have to select any one, right? So now let us just look at the question. In a historical experiment to determine the Planck's constant, a metal surface was irradiated with the light of different wavelengths. The emitted photoelectron energies were measured by applying a stopping potential. The relevant data has been given to us. Let us just see what is to be found. Given that C is this, E is this, Planck constant is this, we have to find, so Planck's constant we have to find from such an experiment. In the history, the scientists were doing an experiment where they were irradiating the metal surface with different wavelengths of light, and the readings are here. At this wavelength, the stopping potential was this. At this particular wavelength, the corresponding stopping potential was this. At this wavelength, this is this. Now let us just find the value of H, and as I have told you, the important thing in this chapter is the Einstein's photoelectric equation, because this has become our favorite part of the question and favorite part of the examiner to bring out the question. So you have to remember what is the photoelectric equation. Now let me just write this equation once again before you. This is kinetic energy of the emitted photons is equals to h nu plus the work function, or you can say here the kinetic energy is the energy with which the electrons are emitting, and this h nu is the energy of the photons which are irradiating over the metal surface. Now in this table you can see, let me just consider this as lambda 1, this as lambda 2 and this as lambda 3. So the corresponding potential voltages will be V1, V02, this is V01, this is V02 and this would be V03, right? Now what I can do from here is, you know that the kinetic energy can be written in the form of E and V. So I will be writing it as EV equals to h nu plus, not plus, this is minus here, right? So this is your Einstein's photoelectric equation. Now from this equation you are having number of lambda and number of stopping potentials. Can we write this nu into the form of wavelength? Of course, So EV equals to hc by lambda minus phi naught, because we know that nu equals to c by lambda. Since nu equals to c by lambda, so we have put this value into this nu. We are having this equation now in the form of lambda. Now from this equation you can write here as EV1 equals to hc by lambda 1 minus phi naught. Phi naught is the work function, and for a particular metal the work function would remain same. Whatever will be the wavelength that will be radiating over the metal surface, it is not bothered about this. The work function will remain same for a particular metal. So for this we can write here as EV2 equals to hc by lambda 2 minus phi naught. Now let me consider this equation as equation number 1 and this as equation number 2. What I can do here is, I can see that V1 and V2, lambda 1 and lambda 2 I am having with me. This is lambda 1, this is V1, this is lambda 2, this is V2, the stopping potential. Now here, this is also the stopping potential. You can write here as EV0. Now what we can do over here is, we can subtract these two equations. So let me just write over here as V0 1 minus V0 2. This will be equals to what? This will be equals to HC 1 by lambda 1 minus 1 by lambda 2. This has common, and this has become as minus 2 phi naught. Right? Now you can see here, since phi naught and phi naught are equal, what I am having, if I am going to subtract this, this will not be the addition, this will be just cancelled out, because phi and phi will going to be cancelled, right? So now I am having this equation. From here you have to find the value of h. So how can you find the value of h? H would be E into V0 1 minus V0 2 divided by 1 by lambda 1 minus 1 by lambda 2. Now just see in the question what are the values that has been given. We have to find the value of h. In the question I am having the value of E. You can just look at here, this is the value of E and this is the value of C. Lambda 1 is 0.3, lambda 2 is 0.4, corresponding V0, V1 are 2 and 1. So I am going to put these values in this equation that we have got. So H will be equals to E. E is 1.6 into 10 raised to the power minus 19. So where is the C that has been gone? This will be C here. H will be E by C, V0 1 minus V0 2 divided by the wavelength. So now we are having something like this, V0 1 minus V0 2. V0 1, you can see from their equation, this is 2 minus 1. Now 1 by lambda 1 minus 1 by lambda 2. You are having in your equation as 1 by lambda 1 is 0.3 and lambda 2 is 0.4. So you can see here 1 by lambda 1 will be 1 by 0.3, 1 by lambda 2 will be 1 by 0.4. So we will be doing it. Alright. Now what you will see here, if you are going to solve it, you will be having your value into the range of 6.4 into 10 raised to the power minus 34. So we have found our answer in this range. Now let us see, is there any option in the question or not? So let's just move to the question, and yes, we can see here this is 6.4 into 10 raised to the power minus 34. So that means the correct approach has bring us to the correct answer. If you are starting your question with the right equation, you are definitely going to reach at the correct target. So yeah, we have completed this question, and now let us just see what is the question number 2. Okay. Okay, so the question number 2 says that a light of wavelength lambda ph, it falls on a cathode plate inside a vacuum tube as shown in a figure. This is a vacuum tube and this is a cathode plate, and lambda ph, say this is lambda ph, photon is falling over this cathode plate. Now further next, the work function of the cathode surface is phi, and the anode is a wire mesh of a conducting material. This is anode and this is a wire mesh kept at a distance d from the cathode. Suppose this is a distance d. Right. Now a potential difference V is maintained between the electrodes. You can see potential difference has been maintained. If the minimum de Broglie wavelength of the electrons passing through the anode is lambda E. If this is the de Broglie wavelength of the electrons, that means this is lambda E according to the question. Now what we have to find in the question? Which of the following statement is true, or which of the following statements are true? We have to tell them. Right. Now because we are solving those questions in which only one option can be correct. So only one option would be correct in amongst these 4. So let us just start with this. For the large potential difference, lambda E is approximately halved if V is made 4 times. So let me just start with the question. Because here potential difference is also applied across this tube, so our energy because of this potential difference will be added to it. Let me just write with the photoelectric equation, and that equation is E equals to h nu, or you can write it as C by lambda minus the work function. Right? This is the equation. Now because potential difference is also applied, we have to add an extra energy, and that would be E into V. Right? Now you can write this energy into one form, that is P square by 2m. You know that there is a relation between momentum and energy and also with the mass. So we can write it as P square by 2m equals to hc by lambda photon, because this is the energy of photon, minus phi plus E into V. Now you are having this equation with you, and what you have to do is you have to find out whether for large potential difference lambda E is approximately halved if V is made 4 times or not. We are having P square by 2m. You know that there is a relation of de Broglie wavelength h by P. This is a de Broglie wavelength. So we can write this P as h by lambda in place of this P. So here P will be h square by lambda E square into 2m. This is the wavelength of electron, right? Because we are just talking about the energy of the electrons that are being emitted. So here the wavelength of electron would be written, right? So now we are having hc by lambda ph minus phi plus EV. Now you are having this equation with you. What you can see from here is that you are having a relation between this lambda E and lambda pH, right? We are having this relation now. This is you can say, because you know that advanced level of JEE is a little bit higher than the JEE mains. So you have to prepare your mind for that level, that you are going to face such question where you are going to apply multiple number of formulas. Suppose we have started with this, now I have applied this, now I am having this equation, and now we are going to solve it. we have reached up to here because in the question I was able to see that there was a relation. They are asking us to find a relation between lambda E and lambda pH. So we have reached up to here. Now let me just see for the large potential difference where V is very much greater than phi by E. So you can see here this is phi. So phi by E would be what? If I am going to divide whole equation by phi by E and V is very much greater than this, then what will happen? That means phi is very much small. In the question you can see phi by E is very much small than V. V is where? Okay, so V has been now here. That means this phi is very much small than this, right? Let me just write for you. You have to understand the question. The question is not so easy. Question has not been prepared as such. You have to apply just a thinking skill of yours, right? So this is, we have been given phi E, phi by E is very less than V. So that means phi is very much less than EV. So from this equation I can say that I can ignore the phi. Now I am having EV and HC by lambda pH. Now you know that we can write this lambda, we can write this phi as HC by lambda E. So you can say that this is very much less than this EV. Now what next? We can, because this is not for electron, this will be for photon. Now because you are saying that this is very smaller than EV, again you can ignore this. So directly we are having a relation that h square by lambda E square P 2pm. This relation is now has become equals to HC by lambda pH plus EV. Because from this equation I have now ignored this phi. We are having this relation with us. So for that, if you are going to, if V is made 4 times, for large potential difference, we have to tell the value of lambda if V is made 4 times. So you can see from here h square by lambda E square 2m equals to EV. Now you can see here if you are going to make the V 4 times, then what will happen? This will get halved, because you can see here the relation between this is V is inversely proportional to lambda E square. Now in the question, if V is made 4 times, this has been made 4 times, this is said that lambda is approximately halved. So that means if I am making this lambda E by 2 square, so what is happening? Is this increasing or not? You can see from here this h square by lambda E square 2m is directly proportional to EV. But from this equation what I can see is V is inversely proportional to this whole term. As I have told you, this question is not so easy. You have to apply your thinking skills, you have to apply the formulas, or else you are going to lose your marks. This chapter is a very scoring one. Why? Because you are just focused on this one particular equation. Chapter is scoring, but if you are going to handle this question in JEE advanced level, you are going to face a little bit tricky questions. So you have to just secure yourself by learning more and more. Now we can see here this option is correct. while I just see the question number, option number B, C and D, in that case, first of all, let me just start with D. Lambda E decreases with increase in phi and lambda pH. So I can see here that there is no relation between lambda pH and phi. So that means this option has been deducted, because there is no relation up to here between lambda and phi, so I cannot correlate with that. So I am minusing this option. If I am going for C option, lambda E is approximately halved if phi is doubled. But here I can see that there is no relation between lambda E and phi, so I cannot correlate with them. So let me just again deduct this option. Now for option number B, lambda E increases at the same rate as lambda pH. For lambda pH is less than Hc by lambda. Let me just see whether they are increasing. This lambda E and lambda pH is increasing by same rate or not. Now you can see in this equation lambda E square, and here you can see lambda pH. Now you can see 1 by lambda E square, 1 by lambda pH, and also with that EV is added. So there is no linear relationship between them, first of all. But secondly, if we consider, yes, they are equating with each other, you can see that one is square and another is having single power. So that means if you are going to increase one, the other one will be getting doubled, right? So that means this relation is not correct. Lambda E increases at the same rate as lambda pH is not happening. So that means we are having one correct answer with us, and that is the option number A, right? So we are now done with this question. Without wasting now time, let us move towards the next question, that is question number 3. All right. So the question number 3 says that a metal surface is illuminated by the light of two different wavelengths, this and this. The maximum speed of the photoelectrons correspond to these wavelengths are U1 and U2. If the ratio of U1 and U2 is 2:1 and value of Hc has been given, we have to find the work function. This is a very simple question. Again, based on one thing, which is the favorite part, that is the photoelectric equation. So let me just write, kinetic energy is h nu minus work function. This we have to find, right? And kinetic energy can be written as half mv square, but here in place of v, u has been given. The maximum speeds are u1 and u2. So I am going to use u square hc by lambda minus phi naught. Now this is my equation. For different wavelengths and for different speed, let me just add 1 and 2 over here. So we will be having half m u1 square equals to hc by lambda 1 minus phi naught. And for the other one, half m u2 square equals to hc by lambda 2 minus phi naught. Now let me just do one thing, because ratio of velocity has been given, u1 and u2 has been given. So let me just divide equation 1 and 2. I will then be having one thing with me, and that is half, let me just write over here, half m u1 square divided by half m u2 square equals to hc by lambda 1 minus phi divided by hc by lambda 2 minus phi naught. You can see here half m cancelled, u1 and u2, the ratio of u1 and u2 has been given. but we are having u1 square, u2 square. So u1 and u2 whole square equals to hc. If hc will be taken common, we can just remove them. But first of all, let me just say value of hc that has been given in the question is 1240 electron volt into nanometer minus phi naught. We have to find the value of phi naught divided by the wavelength. Wavelength has been given as, just look at the question. In the question, wavelength has been given as 248 and 310. So let me just write lambda 1 as 248, lambda 2 as 310. Divided by 1240 electron volt into nanometer divided by 310 nanometer minus phi naught. Now just look at here, u1 and u2 ratio has been given as 2:1. So I will be having here 2:1 square, that means 4. So 4 equals to, if you are going to divide them, you will be having 4 minus phi naught divided by, if you are going to divide them, you will be having 5 minus phi naught, right. So now from here the question has become more simpler. The question is now saying 20 minus 4 phi naught equals to 4 minus phi naught. Now what you can see here, 20 minus 4, that is 16, equals to 4 minus 1, 3 phi naught. So phi naught value will be 16 by 3. What you have to check in this question is whether I have done this calculation correct or not. Because I am not using the calculator right now, you are having your calculators with you. Just do this calculation whether this ratio is coming out to be 4 and this ratio is coming out to be 5 or not. Have I reversed it or not, right? So you have to just take it out, and if you are going to use this, you will be having your phi as 16 by 3. Now let me just see, if I will be dividing, I will be having something 5 point like this. But because I am saying it might be happen that this is the ratio as 5, so let me just write over here as 5 and here as 4. So 5 and 4, and now your relation will be 16 minus 4 phi naught equals to 5 minus phi naught. So let me just again do it for you. 16 minus 4 phi naught equals to 5 minus phi naught, and then you will be having 16 minus phi as 11 equals to 4 minus 1, that is 3 phi naught. So now you will be having your value as 11 by 3, right. So that means your value will be coming out to be approx 3.3 something. Now let us just see whether there is any option available or not in the question, right. So we can see that there are two options, 3.7 and 3.2, right. So if you are going to do the correct calculation, you will be having one particular value amongst this and this. Definitely it will come in the range of 3, because we have seen that the phi, that means work function, was coming in this range, but the correct calculation will reach you up to there. So you have to do the calculation and then you will be able to find your correct answer, right. I have told you the approach of reaching the question, how to start the question and how to proceed in the question. The approach was this: you have to begin the question with this photoelectric equation, move into this manner, reach up to that level, do the correct calculation, and the answer is yours, right. So I am just not aware what the answer of the question is, I am just focused on what the method I am applying here. Now let me just see what is the next question. Let me just tell you, only one option can be correct from this. Either it would be A or it would be B. So you have to check it out. Let us just see the question number 4. Alright. So the photoelectric material having work function phi naught is illuminated with the light of wavelength lambda. The fastest photoelectron has a de Broglie wavelength lambda d. A change in wavelength of the incident light by delta lambda results in a change delta lambda d in lambda d. We have to find the relation, the ratio of lambda d by lambda, and is proportional to what? This we have to find. Now let us start the question. First of all, let me just discuss with you one thing, that whenever you are begin the question, whenever you are going to begin the question, you should focus on firstly one thing, that is which quantities has been given in the question. And main important thing is, firstly just check it out what I have to find out in the question. Here I can see I have to find out this ratio lambda d by d, lambda d by lambda. So which formula can I apply to get this ratio? This should be coming into your mind. Don't go over anything, just focus on your answer. You have to find any relation where you are going to see this relation, this ratio, right? So let me just start with that. Just looking at this, I can see that I have to do some differentiation, because I can see lambda d, delta lambda d by lambda. So that means there must be a differentiation. So now I am going to start, but firstly my favorite thing, that is this I know. Also I know one thing, and that one thing is lambda equals to isn't it? There are two relations of wavelength, this. Now what we can do is, we just know the value of energy, which is this, and we can put this value of energy into this equation and find out the value of lambda. Now from this I can see that we should be having lambda d, that means the fastest photoelectron, the wavelength of photoelectron, right? So wavelength of photoelectron will be in this equation. This can be written as d. Now put the values, lambda d equals to h upon under root 2me. Now just firstly convert this equation as E equals to hc by lambda minus phi naught. Now one thing you have to note here is that this energy is the energy of photon that is coming out. This energy E is the energy of photon, the energy of electron that is releasing, and this is the energy of photon. Now because this is the photon that is being incident upon the metal surface, and this is the energy of the electron. So now here I can write here as lambda d equals to h upon 2me, and E is hc by lambda minus phi. Now what you can do, one thing here is just take the square of this. So you will be having lambda d square equals to h square divided by 2m hc by lambda minus phi. Now you are having this equation with you. The question has now become simpler, because I can see a way, I can see a hope that I will be finding a ratio between lambda d and lambda. Now what I can do from here is, we can say that this is 2m lambda d square equals to h square by 2m, note h square by 2m lambda d square equals to h square upon hc upon lambda minus phi. So you can do this. Now what else you can do from here is, you can just right. Now from here you can see that you are having a relation between lambda d and lambda, and if you are going to find the derivative of both sides, let me just take this lambda d and this lambda to both opposite sides, and if I am just separating this equation, these two terms on the opposite sides and going to differentiate them, I will be definitely having some ratio, that means d lambda by lambda with me. So let me just do that. You are having this with you. What you can do is, lambda d square equals to, you can take it to that side, or you can do it one thing, hc by lambda minus phi equals to h square by 2m into 1 by lambda square. This is lambda d. Now differentiating with respect to lambda, d lambda, to the both sides. Now if you are going to differentiate it, you will be having minus hc by lambda square minus 0, because this is a constant term, so its differentiation would be 0. So now this is again a constant term, and because in multiplication we are writing it as such, we are just going to differentiate this term 1 by lambda d square. So I am going to remove this 0 from here. This will be minus hc by lambda square d lambda, and this will be h square by 2m this will be your differentiation. Now let us just move towards the next step. What would be the next step? And that would be, so now we are having this equation as minus hc lambda square into d lambda, this is equals to h square by 2m into minus 2 into lambda d cube into d lambda d. And now we have to find a relation. The relation is between d lambda d divided by d lambda. This we have to find in the question. And from this given equation, how can we find it? We can see here minus and minus sign are getting cancelled easily. This h and h is getting cancelled. So finally we are having as c by lambda square into d lambda equals to h by 2m. I can cancel out this 2 and 2. So now I am having h by m into 1 by lambda d cube into d lambda d. To find this ratio, what I can do is, I can bring this d lambda to that side and this complete term to that side. So lambda d cube into c by lambda square hm, this hm will be h and m, and this will be d lambda d by d lambda. So now you are having your relation of d lambda d by d lambda in this manner, right? Now from this equation you can see that lambda d cube by lambda square, you are having this relation. Now what you are going to see, we are going to verify whether there is any option in the question present or not. So yes, we can see that option number D is having lambda cube d by lambda square. So that means we are having our answer as correct way. Now we are done with this question. The way to start the question was to know the photoelectric equation and to know the relation between wavelength and the kinetic energy. And that is how we have begun with this question. Now let us just move towards the next question, and the next question is, okay, so the category now has been changed. The question will be of subjective type. You can see here that the work function of silver and sodium are given as 4.6 and 2.3 electron volt respectively. The ratio of the slope of the stopping potential versus frequency plot for silver to that of sodium is, this we have to find. What we have to find? The ratio of the slope of slope 1 raised to slope 2. Slope 1 is for the stopping potential versus frequency for the silver. This will be for silver. Silver is denoted as Ag. And the second one is for sodium. So this will be the ratio that we have to find. Now to start this question, we know that if we are going to plot a graph between the stopping potential and frequency, the graph will be like suppose this is your frequency versus stopping potential graph. So you are going to see that your graph will be like something as this. Since this is a straight line, you can see that there is a relation, linear relation between the stopping potential and frequency. This is your threshold frequency below which no photoelectron emission will take place. Now since we have to find the slope, we will say that this is the slope. This tan theta, suppose this is theta. But we are having one another way to find the slope of this equation, slope of this graph. How can we find that? We know that one favorite part of the chapter is the photoelectric equation. Now let us just start with this equation. The equation will be kinetic energy equals to h nu minus the work function. And you know that this can be written as EV equals to hc by lambda minus phi naught, right? So here you can see that this is your stopping potential, this V. This is your stopping potential. Now if you are going to bring this E to the right hand side, you will observe one thing, that your equation will become as V equals to hc by lambda E minus phi naught by E. If you are going to compare this equation with y equals to mx plus c, where m is the slope of the graph, y is the y-axis, x is for x-axis and c is the constant. So you can just compare this value from here and you will see that this y is the y-axis, that means the stopping potential. This will be your x-axis. You can just write this hc by lambda into the form of frequency. So let me just convert this into the frequency, that means h nu by E minus phi naught by E. Now what you can compare from here is that this is your y, this is your x, and this is a constant term. So that means your slope of the equation is h by E. So we can say that slope of the graph is h by E. Now you can say that this is a constant value because h is the Planck's constant, E is the charge of electron. So this is a constant value, and this constant value, if we are going to take for the silver, either for silver or for the sodium, that would remain constant. So that means we can say that slope for sodium and silver, their ratio will be, their ratio could be what? Their ratio would be same, that means h by E upon h by E, because this is a constant term. So their ratio has come out to be 1. So your answer for the question is 1, right? So now we are clear with this question So we can say that the ratio of the slope of the stopping potential versus frequency plot for the silver to that of sodium is 1. Right? Now we are done with this question. Let us just see what is the next question with us. So the next question is, question number 6 to 7 are assertion and reason type question, where you will be having any assertion and the reason for that assertion will be given, and we have to tell them whether the statement is true, whether this reason is the correct explanation for this assertion or not. We are having 5 options with us, A, B, C, D and E. We have to choose one particular option. Now just let me read out the assertion, which is saying that work function of aluminium is 4.2 electron volt. Emission of electron will not be possible if 2 photons, each of energy 2.5 electron volt, strike an electron of an aluminium. So we can note over here that the frequency, the energy, you can say h nu is 2.5 electron volt. Now let me just read out the reason. The reason for this is that the photoelectron emission of the energy of each photon should be greater than the work function of aluminium. Now let me just tell you that there is a concept of threshold frequency. If you are clear with the theory of the chapter, you will be knowing about the threshold frequency. This is that minimum frequency below which no photo emission will take place. Until and unless your frequency of the radiation will be greater than the threshold frequency, your emission will not take place. So in this case, the energy of photon is 2.5 electron volt, which is less than the threshold frequency. Now let me say that this work function can be written as h nu naught. This is 4.2 electron volt. So that means your energy of the emission, energy of the incident radiation should be greater than this work function if you want the photoelectron emission to take place. So that means the first statement, for the photoelectric emission, the energy of each photon should be greater than the work function of aluminium. This is the reason that has been given. And this was that work function is this, emission will not be possible if 2 photons energy this will strike an electron. Correct? Because there will be no emission if this energy is 2.5 electron volt. So this is correct. And the reason for the photoelectron emission, the energy of each photon should be greater than the work function is again correct, because this is the sole concept of the threshold frequency and the work function. So we can say both the reason and assertion are correct, and R is the correct explanation for this assertion. So we will see the option which one is correct. First of all, if both assertion and reason are true and reason is a correct explanation of the assertion. So we have found that option 1 is the correct answer because both are correct and reason is the correct explanation. So this is the very simple question that we have encountered. Now let us just see what is the question number 7, and that would be again of assertion and reason type. Okay. So the question number 7 says that the assertion is photoelectric effect demonstrates the wave nature of light. We have took this point that photoelectric emission is basically showing the particle nature of light, because we have seen that photon was emitting out. That means it was not the wave nature, it was the particle nature of light. So we can say that assertion 1, from the reading itself, we can say that assertion 1 is false. So now let me just see whether there are any options from where I can deduct this option. Assertion 1 is false. So from these options, I can see that both the assertion and reason are false. I haven't read the reason. Let me just read out the reason first. The number of photoelectrons is proportional to the frequency of light. Again, it is a very false statement. Why it is false? Because we know that the number of photons depends upon the intensity of light but not the frequency of light. So, the number of photoelectron is proportional to not the frequency but the intensity. So, that means again reason is also false. So, we can say that both the reason and assertion are false. These such questions are based on your knowledge, based on your concept whether they are clear or not. So, you can score a very good marks if you are having your concepts about the radiation and photon and wave nature and the dual nature very clear, right. So, now let us just see the next question. Question number 8. According to this question, we are having 8 to 9 those questions that will be having more than one option correct. So, might be there are 2 options that would be correct. So, now let us just read it out. When a monochromatic point source of light is at a distance of 0.2 meter from a photoelectric cell, the cutoff voltage and the saturation current are respectively given. Let me just write for you, at a distance of 0.2 meter, or you can write it as 0.2 meter, the cutoff voltage 0.6 volt and the saturation current 18 milliampere. If the same source is placed 0.6 meter away from the photocell, then what will be the stopping potential and saturation current? This we have to tell. So, they are saying that they are increasing the distance. R would be changed by 0.6 meter. Now, let me just tell you that this saturation current and stopping potential, firstly basically I should talk about the stopping potential. This stopping potential is independent of the distance, because stopping potential is that minimum potential that is applied so that no photoelectrons can emit. This is the retarding potential. But for this case, we can say that stopping potential is independent of the distance. So, if stopping potential is independent of the distance, so that means whatever will be the distance, your stopping potential would remain same. So, from this option, from these 4 options, can I see that 2 options where saturation current will be same? So, from here, earlier the saturation current was, the stopping potential was 0.6 volt. I was saying that stopping potential will remain same, it would not change with the distance. So, I can say that stopping potential will remain 0.6 volt. So, from this option I can see that the stopping potential will be 0.2, wrong. Stopping potential will be 0.6, correct answer. Now, this was for the stopping potential. Let me just speak about for the saturation current. You should remember that the saturation current, this is inversely proportional to R square. So, if I am saying this is inversely proportional to the R square and earlier your current was 18 milliampere and you are changing your distance by 0.6, that means you are increasing your distance by 3 times. 3 times of R, earlier it was 0.2, now your distance is 0.6, that means you have increased your distance by 3 times. Now, if you are increasing your distance by 3 times, your I would be decreased by 9 times, because square of 3 will be 9. So, that means your current will be decreased by 9. Earlier it was 18, so decrease it by 9. So, that means your current will be then 2 milliampere. Your current will be 2 milliampere. Let us just see, is there any option with 2 milliampere? Yeah, there is an option, the option number D, that is saturation current will be 2 milliampere. So that means more than one option correct. We are having B and D as the correct answers of the question, right? So that means you must be knowing the relation where current, the saturation current is proportional to the R, but stopping potential is independent of the distance, right? So now let me just move towards the next question, that is question number 9. Alright, so the question number 9 says that we have been given a graph between 1 by lambda and the stopping potential V of the metals that is having work function as phi 1, phi 2 and phi 3 in the experiment of photoelectric effect. And these are plotted as shown in the figure. They are saying that which of the following statement is or are correct, whether 1 correct or 2 correct. Here lambda is the wavelength of the incident ray. Now we can see from here we are having 3 metals with us whose 1 by lambda is 0.001, 0.002, 0.004. We have to find the ratio of work function. Now just begin with the question. Work function. You know that the work function can be written as h into c by lambda naught. Or to begin the question, what I can say that isn't it hc by lambda. Now what I can do for them is we have to find the ratio of the phi 1, phi 2, phi 3. If I will be starting with this question, what I can see from here is that I have been given the work function and I have been given 3 wavelength in terms of 1 by lambda. So now we are having with us, if I will be writing phi 1 as hc by lambda naught 1. So this is 1. Phi 2 as hc by lambda naught 2. And phi 3 as hc by lambda naught 3. Now your phi 1, phi 2, phi 3 will be equals to hc by lambda naught 1 hc by lambda naught 2 hc by lambda naught 3. Now you know that there is one thing, if you are going to plot a graph between the frequency and the wavelength, this 1 by lambda and V, you will be seeing that your tan theta, that means your slope of the graph will be having something that we are going to find in the option. First of all, just read out the option. The ratio of the work function is this. Second option is the ratio of work function is this. Third option is that the tan theta is directly proportional to hc by E. Now, what I can see from this graph is that if I am going to plot a graph between 1 by lambda and the stopping potential, is this stopping potential? So we are having one thing, this is the stopping potential, so I can write it as V naught also. Now what you can do here is take this hc first of all as common. So you will be having 1 by lambda naught 1, 1 by 1 lambda naught 2. In the question you have been given that 1 by lambda naught 1 is 0.001. Lambda naught 2 is 0.002 and 1 by lambda naught 3 is 0.004. So from here you can have 1 divided by 1000 or if you can take this out, hc by 1000 as common, you are having 1:2:4. So you are having your relation as 1:4. So now let us just see, is there any option? Yes. So the ratio of 5:1, 5:2, 5:3 has come out to be 1, 2 and 4. To begin with the next part, to just move out, to just check it out whether all these options are true or not, or whether any one of them is correct or not. You just note it down and then we'll be beginning with the second thing. First of all, this option will be deducted because we have found out that the ratio is 1:4. So this option is cancelled out. Now to check out these two relations, these two options, we have to do some another thing. So firstly you have to note it down and then we will be moving, right? Alright. So now we are done with this first part, that is the option number A is correct. Now we have clearly said that option B cannot be correct because option 1 is having a ratio of 5:1, 5:2, 5:3. For talking about the C option, I am going to just do the favorite part. Again you will say that this is your favorite part, ma'am. Then I will say definitely this is my favorite part because this is the favorite part of the examiner. Examiner chooses to select those questions which you are having, in which you are having the photoelectric equation. So I cannot do anything with that. This has definitely become my favorite part. Now EV equals to h nu minus work function. Now this V equals to h nu by E minus 5. And also what you can see from here is that nu can be written as C by lambda, isn't it? Because nu, so we can write it as C by lambda. So I am going to write it as V equals to h C by lambda into E minus 5. So now what you can observe here, one thing, that we are having V equals to h C by E into 1 by lambda minus 5. Compare this equation with again y equals to mx plus c. You know that we are having a graph in the question and the graph is plotted between the stopping potential, that is V. Let me just remove from here. This is plotted between V and 1 by lambda. And again you are having your x-axis as 1 by lambda and your y-axis as V. That means this. So we can compare y equals to mx plus c. So the slope, that means tan theta, from this equation will come out to be, because m is what? M in this question is this and m is slope. Slope is written as tan theta. So I can write it as tan theta equals to hc by E. Now let me just see what was the question. Option. Here you can see that tan theta is directly proportional to hc by E, where h is your Planck's constant and c is the speed of light. And yes, we have got this situation, this tan theta equals to hc by E. So that means this option is also correct. Now let me just verify the option number D. The violet color light can eject photoelectrons from the metals 2 and 3. Now to start this, to just begin with this option, I must tell you one thing, and that one thing is threshold wavelength. You would have heard one term, that is threshold frequency. Threshold frequency is the minimum frequency below which no photoelectron emission will take place. And the threshold wavelength is that maximum wavelength above which no photoelectron emission will take place, right? So from here I can just find out the wavelength of the violet color and the wavelength of these three. So we will be saying that since we are having 1 by lambda 1 as 0.001, so from here you will be having your lambda 1 as 1 divided by 0.001. So that means earlier this was in nanometer, isn't it? It was given in nanometer. So if you are going to convert it in the angstrom, you are having your lambda 1 as this, right? Now just time to do for the lambda 2. This was 0.002 nanometer. So your lambda 2 would be 1 upon 0.002. So that means angstrom. I am converting along with that in the angstrom. Now for the lambda 3, we will be having 0.004 nanometer. Now for that, you will be having your lambda 3 as 1 divided by 0.004. That means you are having your, this will be in angstrom. Now what you can see from here, that your violet color light has the wavelength of lambda 4000 angstrom, right? Now if the option is, just let me see the option, the violet color light can eject photoelectrons from the metal 2 and 3. It can eject for the metal 1, I would say that lambda has come out to be 10 raised to the power 4. For the lambda 2, metal 2, lambda has came out to be 5000 angstrom. For the metal 3, lambda has came out to be 2500 angstrom. Now you can see from here, your violet color, that means having 4000 angstrom, it will be only able to eject the electrons from those metals whose wavelength is greater than this. So that means it will be able to eject the electrons from metal 1 and metal 2. And in the option we have been given the metal 2 and metal 3. So that means it's not the correct answer. It can only eject the electrons from the metal surface for which its wavelength is less. So for metal 2 and metal 1, its wavelength is less. Comparison, if we will do the comparison, we are having 10,000 and this is 4,000. So that means it can emit the electrons. For the metal 2, this is 5,000, this is 4,000. So that means it again can eject the electrons out of this. But for the metal 3, we can see it is 2500 and it is 4000. So it won't be possible for the violet light to eject the electrons from this metal surface. So that means option D is not correct, right? So let me just tell you that it is a frank opinion that for the options for the question which is having more than one correct answer, you have to verify for all the 4 options that you are having, right? So now let us just move to the next question. Yeah, so finally the answer is this and this, okay? Question number 10 to 11 are comprehension type, and this is the last category of the question, because we have done all the type of question: assertion type, subjective type, only one correct, more than one correct, and now it is comprehension type question. And these are the last 2 questions where we have been given the work function of metal as ionization energy of hydrogen atom. So let me just write over here work function of metal A as ionization energy of hydrogen atom. And work function of metal B, Wb, this is equals to the ionization energy of helium atom. helium ion in the second orbit. So here n equals to 2, and this was for the first excited state. So that means again n equals to 2, first excited state, that means not the ground state, first excited state would be 2. So that means in here the n will be equals to 2. And now photons of energy E are incident on both A and B. Maximum kinetic energy of photoelectrons emitted from A is twice that of photoelectrons emitted from B. So the given equation, the given relation can be written as kinetic energy of the electrons emitted from A is twice the kinetic energy of B. Now what I can do from here is, first of all, I will find this energy. How I can find this energy? If you know the relation that En equals to 13.6 by n square. So put the value of n, that is 2 here. So you will be having 13.6 by 4, that means you are having 3.4 electron volt with you. For this Wb, that means energy of ionization energy for metal B. Now just look at this one thing, it is a helium ion, and you know that helium is what? 2He4. Now this is the ion, so we are not bothered about ion, we are just concentrated over the helium, and the atomic number of helium is 2. You can write here as Z square also. For the hydrogen, Z was 1. So that is why we were having 3.4 electron volt. Now for here, En equals to 13.6 into 2 square by 2 square, because n is 2. So this has been cancelled. We are having En as 13.6 electron volt. Right. Now I have find out the energy of the ionization. Now from this equation, Ka equals to 2Kb. What I can do is, first of all, we have to find the value of energy, right? To find this value of energy, we can apply one thing over here, and that would be kinetic energy equals to h nu minus work function, right? And so kinetic energy, this, suppose this is for A. So let me just write over here Ka. This is as energy minus work function for A. This is our equation that we are having. Now for the B, we have Eb minus Wb, isn't it? So now what you are going to do here is, let us just subtract these two. We are having equation number 1 and 2. So that means we will now be having, because Kb is what? Ka is 2 Kb. So let me just write over here one thing, that 2 Kb equals to Ea minus Wa. Right? Now what I can do, this is the value of Kb. So just put this value of Kb to this side, and so you will be having Eb minus Wb equals to Ea minus Wa, right? Now what you can do is, just open this bracket, to Eb minus to Wb equals to Ea minus Wa. You are having your energy with you as such, and you know that you are having Wa as this. This is your Wa, and your Wb is this, right? So you can put this value up to here, and then you will be able to find the value of this. Now what we can do over here, one thing, let me just remove this. We are having 2EB equals to minus 2WB equals to EA minus WA. So you are having 2EB minus 2WB. WB is what? This was the work function. So I have denoted, yeah, you can correct it out. This is not the work function. This is the energy. So this is EA and this is EB. Just put these values into this equation and then you will be having 2 into EB. EB is 13.6 minus 2 into WB. We are not knowing about the WB because this is the work function. This is EA. EA is energy of A. This is 3.4 minus WA. Now from here you can see that multiply this, you will be having 13.6 multiplied to 27.2 minus 2WB or you can do one thing over here, just bring this minus 3 point here and you are now having 2WB minus WA. Now there is a twist in the question and the twist is, first of all just subtract it out, then I will tell you what the twist is there in the question. So subtract 27.2 minus 3.4, you will be having 23.8. And the twist in the question is that because you are having two different matters, so definitely your work functions will be different. Now you have to find it out from the work function of metal B to the A. So value of E that we have found in the question is 23.8 and this is nothing but this is 2W minus WA. You can see that this is nothing but the energy. Work function is what? Work function is energy. So we have find it out that energy is equals to 23.8 electron volt. And yes, we can see in the question that there is an option, the option number 4, 23.8 electron volt. So that means we have definitely done this correct. So now let us just see what will be the second part of the question. To go to that part, you can just look at the question, alright. So that question will be, okay. The difference in maximum kinetic energy of photoelectrons from A and from B. We have to tell them whether there will be increase with the increase in E, decrease with the increase in E, first increase then decrease with the increase in E, or it will remain constant. The difference in maximum kinetic energy of photoelectrons from A and from B. You know that the difference of kinetic energy from A and B, the formula was or you can write it as energy of A minus WA. KB was energy of B minus WB. In the question, they are saying the difference is the difference in maximum kinetic energy. So that means Ka minus Kb. This is equals to either it will be increasing or it will be decreasing or it will remain constant. So let us just see, that would be Ea minus Wa minus Eb plus Wb. Now what you can see from here, we know the value of Ea and Ea and Eb. EA was 3.4 minus WA, and your EB is 13.6 plus WB. And if you are going to solve this by putting the value of WA and WB, you will see that your answer will be a constant term. Let me just say that by putting the value of WA and B, you are having your energy as 10.2 electron volt, and this is a constant term. So what you can observe from here is that you are having no relation of difference of kinetic energy with increase or decrease of energy. You are having a constant value with you, and so you do not have to bother about whether there will be increase or whether it will be decreasing. You are just going to take over this, that it will remain constant. If you are going to find the difference, it will remain constant. So yeah, this were some questions which were based on the JEE advanced pattern. So just good luck for your exam. Just keep practicing all the question. Do more and more question, more and more practice from the number of books, because hard work is the key of success. So just do hard work and the success will be yours. Just take care, stay safe, bye bye.